Hello everyone and welcome to this YouTube video. Today we will be doing something really exciting. We are going to spin up our own Kubernetes cluster completely from scratch the hard way. That means we will start with provisioning all the required infrastructure. We will generate our own self-signed TLS certificates for a secure communication. And we will also look into the cluster networking, the container runtime, and how we can enable DNS resolution inside the Kubernetes cluster. Before I jump right into, I just wanted to mention that this video is inspired by Kelsey Hightower's Kubernetes The Hard Way repository, which is a great repo and lists down all the different steps and documents what is needed to provision the cluster from scratch. I can highly recommend you checking that out. As part of the video, I slightly modified a few of the steps, but still, I would definitely check this repo here out. And with that being said, let's jump right into it. Alright, so before we actually start with spinning up the infrastructure, we first need to create a plan how the infrastructure should look like. And the reason why this is really important is that we can ensure that there will not be any IP address clashes later on, because that will cause trouble when we actually spin up the cluster then. We're going to use Microsoft Azure as our cloud provider of choice. And the reason for that is pretty simple. I personally haven't worked with Microsoft Azure before, and I wanted to get some more insights there. So if you're maybe already familiar with Azure, maybe you want to try out AWS or GCP from Google. That's really up to you. But the other cool thing about Microsoft Azure is that you get some free credits there. I think like $250 within a free plan without any costs for you. And with that free plan, you can spin up the exact infrastructure what we are going to do. And that was really important for me that everybody of you could theoretically follow along. All right, so as you can see here, we are having a virtual network containing all our different components. For example, our control plane subnet on the left with 32 possible IP addresses and a worker node subnet on the right with, again, 32 possible IP addresses. Of course, to mention it, I hope that's clear, but this is not reflecting a production grade or a setup which you would use in a real case because, for example, we are not having enough IP addresses to scale up a lot of nodes if we would want to, but for our testing and learning experience, that's more than enough. Same goes here for the control plane. We're only going to create one control plane node and two worker nodes, which is also not how you should do it in production. But the reason for that is simply that Azure only allowed me to create 3 virtual machines, and I decided to go with one control plane and 2 worker nodes. The other important thing is, which we can see later on when we actually start the Kube API server and the Kube controller manager, that we are giving different cluster CIDR and a service cluster CIDR. And the cluster CIDR will be used to assign pod IP addresses later on. So there you can see we have a pretty big range. I think 10 to 100 is a pretty common range, which you normally pick for your pod IPs. And we are going to go with a 1096.00/24 IP address range for our service cluster CIDR. And the reason for that is there's a great example in the Kubernetes documentation where they explain the service cluster IP allocation. So a certain part in this example here will be static IP addresses. It will be 16 in that example, and the rest will be dynamic IP addresses. So this will also be useful later on when we, for example, configure our DNS resolution, because there we want to use a static IP for our cluster DNS service, but more to that later, just to keep the reason why I choose those ranges in mind. And the other thing which we will need is our external static IPs. And on one side, we are going to communicate to the Kubernetes API, for example, via kubectl. And on the other side, so there we will not communicate with kubectl to the worker nodes, but we are going to SSH into all of those instances, of course. So there we also need to have some kind of access. Okay, so with our plan now being ready, we can now jump into actually provisioning the infrastructure. So we are going to use Terraform to spin up our infrastructure. And of course, you can use any tool you like. You can even provision it via the UI if you want to handle it outside of any code configuration. That's up to you. I just think Terraform is pretty popular. Most of you have probably already worked with Terraform in some way, and also the code is quite easy to read. So I transformed the diagram, which we saw earlier, into the Terraform code here on the left. It's about 150 lines of code. So if you're interested in how all of that is looking in detail, I will put all the files in a GitHub repository so that you can follow along. But it's really nothing else than the diagram which we talked about earlier. Okay, so with that being said, we can jump into the command line and first of all initialize Terraform. I already did that, but yeah, just for the sake of completeness, I'm doing it again. And then we can say Terraform apply. And normally you would of course also do a Terraform plan first. And also I already authenticated myself into Azure. So you might need to do that if you're following along. Okay, so now we confirmed that we want to spin up the infrastructure, and we will see us in a second once the infrastructure is ready. The Terraform code is finished now, and if we look into the Microsoft Azure console, we can also see that everything is looking good. So our Kubernetes resource group got created. We can see our control plane, our public IP address for the control plane instance, and also our worker node instances. So as our infrastructure is looking good, we can now focus on generating the self-signed TLS certificates. So before we actually start generating all the different needed TLS certificates, I want to highlight that part of the Kubernetes documentation here, PKI certificates and requirements. And this is a great starting point for understanding which different certificates are needed and how they should be configured. So there are some very important things to consider when you generate the certificates, because otherwise your cluster will not work. For example, when we create the Kube API server kubelet client certificate, the system masters organization needs to be set, which is responsible for the authentication when the kubelet tries to authenticate with the control plane. And also it's important to give for some certificates the expected IPs. And yeah, also all the different locations are mentioned here in the document where which certificate should be stored. And what's also mentioned here is what we will need is kubeconfig files, for example, for our administrator, which we can use as a admin of the cluster, or also what different components of our cluster will use when authenticating or when communicating with other components. And all of that is mentioned here and really, really useful. So definitely check that out. I already created a OpenSSL config file for us so that we don't need to do everything from scratch. We can see here, for example, the Kube API server one. I also added a few comments which I found useful during the setup. But one important thing what we can, for example, see here is that I already added the public IP, which we created a few minutes ago, and also other things which are required. And for example, a really important thing which I have removed by accident, it seems, we need to say system masters here, because otherwise kubelet, you can see it's the Kube API, so the kubelet client certificate will not be able to authenticate with the Kube API server. Okay, since the system masters organization name now is back in place, that should be good. And we could start with generating our certificates. Now, one more important thing to understand of the way how we're doing it here is that we are taking the approach with a root certificate authority and a Kubernetes certificate authority. And the way it works is that we first of all generate our root certificate authority, which will be like super private and we don't want to share that with anybody. And then we are creating an intermediate Kubernetes certificate authority. And that intermediate Kubernetes certificate authority we will use to generate our certificates. That's basically what's mentioned here on the right at the beginning of the documentation. You can also do the same for etcd or Kubernetes front proxy, but we are not needing that in our setup because we are running etcd just on the control plane, so we don't have any cluster mode there, and yeah, it's simply not needed for our setup, but of course you would need that. With that being said, I also prepared a small helper script already in beforehand. You can see, for example, here we have a function to generate the certificate authority. First, we are generating the root certificate authority and then the intermediate Kubernetes certificate authority. And then we have another function for generating the certificates itself. So we are first creating the key, then a certificate signing request, then we are actually signing that request, and then we are validating and verifying the created certificate. I also have a function to generate the kubeconfig files mentioned here, and also I have a few helper functions to copy that over to our different instances, and that we don't need to copy everything manually. But I would highly recommend you to maybe not use that script here. I will still link it in the description, but maybe you want to try on your own to generate the certificates and to copy it over, because that was one of my big learnings when I did Kubernetes the hard way initially, that I didn't expect there are so many different certificates involved in the background, which also need to be maintained at some point. That's normally happening automatically under the hood. But there I realized, okay, there's maybe more going on than I initially expected. So with that being said, we can now start starting that script which I mentioned, the gen-cert script. And as I said, what this will do is it will generate the certificates to us. We first need to say yes, that we are trusting the different instances which we just created. Yes, we are trusting that. And now the script is starting to work, generating the different certificates for us and copying it over to the different instances. So once this is done, we will CS again and SSH into the control plane instance. Now, as we have generated our TLS certificates, we can start with actually setting up our control plane. And before we start the different components, we should first have a look at the architecture of a Kubernetes cluster, where the Kubernetes documentation is once again providing a really good insight. And we are right now in particular really interested in the left side here, the control plane. And what we can see here is that we need the kube API server, we need the kube scheduler, the kube controller manager, and etcd. What all those different components are doing, you can read detailed here in the documentation. We will today focus on how we need to set up those things. Optionally, you might need a cloud controller manager, which in our case is not needed. With that being said, we can start with setting that up. And the first thing which we will do is creating the etcd configuration and downloading the etcd binaries actually. So I extracted that part from their documentation here, which I just pasted in the terminal, and I can just hit enter, and this will download and move etcd into the right location so that we can start it up. And now the next thing which we will need is we need to create a systemd file in order to start etcd. So there are also other ways how you could start etcd in theory. They are also having a good documentation about the different ways to start it up and which different flags you need to provide them. But in our case, it's pretty easy, as you can see here, because we are just running it on that control plane node on that particular port. So we don't need to do much here, and we can just hit enter. Yeah, I first need to be super user, and we can hit enter, and now we created that file. And now, last but not least, we can reload the systemd daemon and start the etcd service, and then we can look at the logs, and this is looking good. So the next step will be to set up the kube controller manager, and to do so we again will create a systemd config file. And there are two flags which are interesting this time. So it's the cluster CIDR, which we can see we are giving 10.200.0/16, which will give us 65,000 and a few more IP addresses for the pods, and the service cluster IP range again. Maybe one thing which is good to know is that the very first IP of the service cluster IP range will be allocated to the kube API server. So Kubernetes out of the box will create a service, a cluster IP service, which will point to the kube API. And we can create the file now, and same like we started etcd and the kube API server earlier, we can also start the kube controller manager. And this is looking good as well. So last but not least, we will need to set up the kube scheduler. And guess what? We will do the same again. So we paste in the command to create the needed configuration. This time it's looking slightly different, but not much changed actually. So first we are creating a config file called kubescheduler YAML, which will refer to the kube config, which we generated. And then we will give the path to that config file and start this kube scheduler with that command here. So we can hit enter. Now we created the two files. And now, last but not least, we again can start the kube scheduler. It's starting up now, and this is looking good. Our control plane should be up now. That means we can now focus on the worker nodes. And if we look at the Kubernetes architecture again, we can see the critical piece which we will need on our worker nodes is the kubelet. So the kubelet is essentially responsible for ensuring that the containers are running. And another optional component would be kubeproxy, which in our setup is not needed because we will use Cilium for our container network interface. More to that later, but what's important right now is that we are going to set up kubelet. And to do so, we will jump back to our terminal, and we will first of all start with downloading different binaries. So here I again prepared a command to do so. And you can see we're downloading the kubelet binary and two more binaries actually. And that's for containerd and runc. And containerd is the container runtime interface which is used by the kubelet. So kubelet itself is not actually running the containers. It's using container runtimes. And there we are using containerd. There are also a few other container runtimes out there, which you maybe have already heard of, but we will go with containerd, and containerd itself will need another lightweight, more low-level container runtime called runc. And the way it works is basically that containerd is responsible for that image storage, for that image pulling, for all that life cycle around the containers, and runc is in the end responsible for actually starting and running the containers. So that's how they are interacting with each other. And if you want to use containerd, you will also need to install runc. That's also what we will do now. So we will start with setting up containerd and runc. I prepared another command here, which is creating a default config for us in the systemd directory. And it's not doing much, just creating the config and copying the files under the expected locations. So as we only created a default file, we now also need to configure the default file slightly. And in our case, we need to do sudo we need to go to the containerd config.toml, and there we need to go to run C options. And in our case, we need to set systemd cgroup to true instead of false. So that's really important for our container runtime to work as expected. But as we changed that now, we should be good. That means we can do a containerd restart. And yeah, then everything should work as expected. We can have a look at the logs. So we can say shonelctl containerd. And yeah, containerd successfully booted. So I guess we are good here. All right, so now we come to an interesting part. Now we need to set up kubelet. And if we look at the command, how we can configure it, you can see we are again creating the kubelet config. So it's pretty similar like what we did for the kube scheduler. We're giving a path to our certificate authority file. And one important thing, maybe you remember what we mentioned in the beginning, that we want to use a static IP for our DNS resolution. And that's what we are doing here. We are basically saying, look at the service with the IP 10.96.0.10 to resolve the DNS names. And that's an important configuration where, for example, static IPs can be really convenient, because even though we didn't already set up any DNS related things, we can already reserve that IP and make use of that later on. In addition to that, we are configuring a few more paths to certificates. We are mentioning containerd as our runtime. And down here, we are giving our kube config for node 1 in that case, and a path to the kubelet config up here. So we can hit enter, and I made the same mistake again. I'm sorry. So let me paste that again. Now we created that files. And now let's give it a shot and start up the kubelet. So we reloaded the daemon, started kubelet, and are now looking at the logs. And this is looking good, I think. So it's not exiting. We are not seeing any bigger issues. And we can, for example, also see an interesting thing here, that we have a pod CIDR assigned to that node now. So the kube controller manager assigned now a CIDR to that worker node 1, on which will be used in order to give then IP addresses to our pods, which we will schedule later on. So that's pretty cool, and that theoretically means our Kubernetes cluster is ready to go. That was easy, wasn't it? Well, I fear I need to disappoint you, because we are not there yet, but we are close. So I went back to my normal Ubuntu machine, which is not the control plane or not a worker node. And if we do a kubectl get nodes now, we will see that there's actually coming back something, but that the worker node 1 is not ready yet. And if we describe that, or by the way, one cool tool which I can recommend you is K9s. So you can just say K9s, and then you will get that overview about your cluster here. And it's really easy to navigate through your cluster with K9s. Of course, you can also use the command line, especially in the beginning. It's useful to get a feeling for the different kubectl commands. But we can see here now worker node 1 is not ready. And if we hit D, we can say describe, and we can see container runtime network not ready. So we're nearly there, but the container runtime network is missing. And if you remember in the beginning, I mentioned we will use Cilium to for our container network interface. And that means once we installed and set up Cilium now, we should be good and our worker node 1 should be running. So with that being said, let's set up Cilium. So one of the main responsibilities from the container network interface is, for example, setting up routing rules so that our requests which hit the Kubernetes cluster can actually be forwarded to the pods in the end. That means it's really important for a working Kubernetes cluster. However, it's not a runtime requirement. That means we could, for example, install a CNI, a container network interface. We can spin up pods, and then we uninstall the container network interface again, and our pods would still work because the CNI plugin would configure the routing rules, our requests would hit the pods, and everything works. But the moment we want to remove the pods again, then we would be in trouble. But yeah, just to keep that in mind. Another thing which I did in the background, I also executed the same commands on worker node 2, which we executed on worker node 1 before. And now you can see we are getting back both of our worker nodes and both are not ready yet. We will be installing Cilium using the Kubernetes package manager Helm. So this makes it really easy to install different things in your Kubernetes cluster. You can see the command is pretty straightforward. We will configure it a bit more because we slightly want to deviate from the default installation. And the big reason for that is the IP address management. So it's really important to review and see the different possible features which you can use here. And you can see the default is the cluster scope. And for the cluster scope setup, Cilium will basically create a new pod CIDR range, which will be used to allocate IP addresses for the pods. And that, of course, again, must not conflict with the other IP address ranges, which we already configured. But that's not the feature which we will go with. We instead will go with the Kubernetes host scope. So we will rely on the pod CIDRs and the different pod CIDR ranges which are allocated to the different nodes. And that's the way how we will configure Cilium. In the end, both of those approaches are pretty similar, but yeah, just to keep that in mind. So if we jump back to our terminal, we can still see our nodes. And let me just clear that. And we can now, run the Helm upgrade command. So in our case, the Helm upgrade or Helm install, it's in the end also doing an install because of the -i flag here. We are giving our Kubernetes service host, which is the internal IP address of our control plane instance, the port. And here the important thing is we are saying, okay, our IP address management mode should be Kubernetes, not the default one. And now we can hit enter and Cilium should get installed now. So we're seeing that the deployment was successful. And now we can say Cilium status. And yeah, we are right now still getting errors, but we can say watch. Was it? It was wait, not watch. And yeah, now we can see the pod is pending and not everything is up yet. So I span up another terminal here on the right to run the kubectl get pods command at the same time. And okay, now we can see it's already finished. I was too slow, it seems. Cilium should be up now, so the command here finished, but it was still showing errors. Let me do that again. Okay, now it's showing okay. Operator is also okay. Envoy daemons is also okay. That means we should be good. All right, so now we did a lot of configuration and we are nearly at the end. So you can see both of our worker nodes are now in a ready state, which is pretty cool. And what we can do now is we can test if our cluster is working as expected. So we are here in the pods in the default namespace, and I prepared a small test file here on the left. So it's just an Nginx image. It's not doing much and a service, and we will apply that to our Kubernetes cluster now. So we can say just kubectl apply pod.yaml, and we can see the container is creating. It should be in a running state in a second. And we can also see our service, which got created with a dynamic IP address for the service now, not a static anymore. And if we go back, yeah, our pod is running now. We can also, exec into the pod. So we're right now in the test pod. And that's looking good. So we are able to exec into the pod. Let me exit here again. We are able to get in a running state. We are able to view the logs. So that's basically a working Kubernetes cluster. However, one last thing which is missing, and I promise it's the last thing, if we go into the pod, and if we say now curl google.com, for example, you will see it is not working. So it will time out and say it was not able to resolve google.com. And that's because we didn't install our DNS service in our cluster yet, but that's what we will do now. So the normal tool which is usually used for enabling DNS resolution in the Kubernetes cluster is CoreDNS. And same like Cilium, we can install that pretty easily with Helm. So the command is looking like Helm. Namespace would be kubesystem, install CoreDNS. And here, if you remember, we reserved 1096.0.10 on the kubelet. And that specific reserved static IP address we are now giving to our CoreDNS instance. So I will hit enter here and it will install CoreDNS now. And if we go to the kubesystem namespace, we should see the CoreDNS pod coming up. It's right now still in container creating. Now it's switched to a running state, which is cool. And now it should also turn ready in a second. So we can now go back to the default namespace and recreate our test pod. And now our test pod is coming up. It's in a running state again. We open my shell and go into the pod. And now we can say again curl google.com. And boom, now we are getting something back. We are able to reach Google and we are able to reach the internet. Same goes, for example, if we spin up another pod, we can also use now the Kubernetes internal DNS resolution, for example, via the service to reach the pod. That means for us, our setup is finished. Our cluster is up and running. We can create pods, we can create services. Of course, there are a few more things we could install and fine tune, but the overall basic functionality is in place and we did everything the hard way, which is really awesome, I think. And yeah, I hope you enjoyed that video. I hope you were also able to take away a few things while setting this up. I love doing it the hard way. And yeah, thank you for watching and see you again. Bye bye.